Danny Shapiro is Senior Director Automotive at NVIDIA and responsible for AI and self-driving cars. He serves at the advisory board for the LA Auto Show as well as the Connected Car Council and the NVIDIA Foundation for Cancer Research. Danny owns a Bachelor of Science in Electric Engineering and Computer Science from Princeton, as well as an MBA from the Haas School of Business at UC Berkeley. He has an extensive experience of 11 years with NVIDIA, plus another 6 years with AMD, and with that, he's probably one of the most experienced executives in terms of chip technology as well as autonomous driving. Danny lives in Northern California, and his house has a solar system that is charging his AI-driven self-driving car. Danny, my first question is a little bit an unusual one. You're living in Northern California, you have a solar system, and you have an AI-driven BEV. So my first question is, what kind of car are you driving? What kind of solar system do you have?
So it was actually about 15 years ago, we put on a 30 kilowatt system to be able to generate all the power for the house. It, of course, is able to generate more during the day than we're consuming, so we sell that back to the utility, and then at night we consume at a lower rate. So it essentially has eliminated virtually my entire electric bill, and it's able to charge my vehicle. When I charge a lot, I have a little bit of expense, but for the most part, the sun year-round takes care of my house and my car.
That's awesome. But so what kind of car do you have? Is this an AI-driven BEV? I'm just curious about that.
So it's a Tesla Model S, and
Okay.
it has the NVIDIA autopilot inside. So it's
Okay.
the first real autopilot from Tesla, and it gets software updates. And so we've been working with them for many years, and now have many more customers that we're working with, of course, in terms of developing all types of technologies inside the vehicle for an AI cockpit to autonomous features from ADAS to higher levels. So there's a full range of solutions that we deliver, and it's all hardware and software that's developed by NVIDIA, along with tier ones and with automakers. That's really the philosophy of our business, is being a technology partner to the auto industry.
Yeah. So that sounds like the best of all worlds. I mean, everybody's looking for a setup like the one you have since 15 years. So congratulations for that early decision. I think it's a smart decision. So having a solar system that powers your vehicle or even your house is just, I think, a very good gut feel, right? Throughout the day, and everything is, you feel like you are doing the right thing for the environment. And actually, I didn't want to dive just in the beginning into Tesla, but here we are. So I'm obviously aware about that Tesla has been working with NVIDIA for many years, and the early version of the autopilot has been very well received also with Mobileye and with what AP1 was able to do compared to the years after Tesla decided to develop its own system, its own computer, its own chip even. And so that leads me to the question, and you may not be able to answer that, but what is the reason that this partnership did end? Why didn't NVIDIA and Tesla work together until today?
Well, actually, NVIDIA and Tesla still work together today. Their data center, where they do all the training for the AI, is based on NVIDIA. So we have a very close relationship with them. The technology evolves very quickly. We have many generations under our belt in terms of our GPUs and our SoCs, our system on chips, that are used in vehicles, but they're used in data centers around the world. They're used at the edge. They're used in PCs. So we have a very diverse business. And so we've created a highly programmable, high performance AI platform that is used in many different industries. We have the most advanced solution on the market today for the automobile as well. I think in some cases, some very few car companies, and in fact, only one that I can think of, vertically integrates more than anybody else. They make their own seats and they now make their own chips. But I think what's interesting is you look at their approach and you look at NVIDIA's approach, we have a lot in common. We recognize that the core element for the strategy of an EV or an autonomous vehicle in the future is to have centralized computing. You need an AI supercomputer in the car, and you start with that and you build the software around it. It's a software-defined vehicle. It's not take a legacy car and start adding components to it. And so this is what is critical, is that the future is all about software, and it's all about having over-the-air updates. But the architecture of the car has to be designed from the start for that. And that's what we essentially announced with Mercedes-Benz. Just the other month, Mercedes and NVIDIA coming together to create a true software-defined architecture for the entire fleet. So it's not just a premium offering, but it's a standard element of every single vehicle, from the entry level to the high end, which will then centralize the computing. It will replace a lot of the different electronic components in the car that are individual fixed functions. And so everything in that car then can be improved, it can be updated, it can be modified. There might even be features that when you buy the car, you don't know that they're coming, but future software will then activate or create. Just like your phone, right? When you buy the phone, you don't know the apps that you're going to install a year from now. In some cases, they haven't even been thought of. But some developer will create a really cool new app, and you'll be able to download that. And we see the same model happening for the car, and that's what we're doing with Mercedes-Benz.
So Mercedes-Benz is certainly one example, but you have a ton of customers in the automotive industry, a lot of big names. And so if you look at this kind of customers, what are the different approaches you're pursuing, and how are they working different with you? Let me add to that. You mentioned just vertical integration, which obviously is a term that's very much associated with Tesla nowadays, but it's not exclusive. So everybody can do that, right? So that's an area where you are a classical tier one supplier, if I'm not mistaken, right? So you're delivering solutions for suppliers as also for OEMs, which is obviously not as much vertical integrated like, for instance, a Tesla is. What are the pros and cons for these two concepts?
Well, again, I think you can look at us as a tier one supplier from a technology perspective, from a lot of our software, but it's still very much a triangular relationship with the OEM, a traditional tier one supplier who would be integrating the sensors, who would be building the box, and then NVIDIA, we supply the hardware and develop a full software stack. But I think a difference is, again, we're developing an open product. And so a traditional tier one supplier and the OEM have the ability to add layers of software. They have algorithms, they might have applications, there can be third-party applications. And so it's really a living, breathing organism that goes inside the car. It's not fixed function. It's not like there's a list of specs. We develop to meet the minimum level of those specs and we ship that product. It's an ongoing relationship. So you can think of a whole teams of engineers, some software engineers and AI experts at NVIDIA that are working continuously behind the scenes to make your car better and to continue for the life of that vehicle to enhance it. Again, just like your phone.
Yeah,
you would never think about buying a new cell phone that doesn't get OTAs. You wouldn't do it. And I think once people start to see that this model is coming to the vehicle, it will be impossible to go back. Once you experience a new feature, whether it's a lane keeping feature, a blind spot, an automatic parking, it's really hard to give that up in your next car. And once you then have that leap to a whole new software-defined architecture where virtually everything in the car can be updated and enhanced, it's really difficult to go back and not have that kind of flexibility and openness in your car. So that we work, your original question was, we work with many car companies, you're right. There are hundreds and hundreds of car makers and truck makers, mobility companies, the shuttle companies, the robo-taxi companies, but then also a big part of our ecosystem are those traditional tier one suppliers, the sensor companies, the mapping companies, it's all integrated in. There's a whole other part, whether we talk about it today or not, is on simulation. And the testing and validation of these systems is a huge part of the development. So we have a whole ecosystem that's centered around how do we use simulation to improve the systems, to test it, to create hazardous and rare scenarios that we can do in a simulator because it's too dangerous to test this in the real world. So there's literally hundreds of companies that are building on NVIDIA, and we work with them depending on what their business model is. So they might be doing a level 2+ system. They might be trying to do a level 5 robotaxi, but the drive platform is scalable. And so the software base is really not that different whether you're doing level 2+ or level 5. The difference is in what's the backup of the system. Is there a human there as a backup, or do you need a bunch of different redundant sensors and software algorithms and hardware platforms in case there's any kind of error in the system or weather change or whatever it may be?
So thanks for that. Let's discuss a little bit the service and offerings from NVIDIA so that everybody can sort this out clearly. For me, it's still a little bit confusing. I mean, I understand what you're delivering to certain OEMs and automakers, and I understand there's a bandwidth of solutions you're providing. Although on the hardware stack is probably more or less, as you said, the drive solution, which is the one product. But I've also been reading about operating systems. At least it's mentioned. So are you also delivering operating systems for automakers? You do.
Yeah, so our drive platform is base level hardware, and it is scalable. So you can have a single SoC, a system on chip. Today, our Xavier processor delivers 30 TOPS. That's 30 trillion operations per second. If you go back a couple of years, that was a data center, like a full room full of servers. So now it's on a single chip. Our next generation, that is what we announced with Mercedes, is called Orin, and that's 200 TOPS. So 200 trillion operations per second is the performance of this single chip, a little bit bigger than your thumbnail. So that's kind of a performance range for a chip. Now you can have multiple chips in a vehicle, but you can also add some of our GPUs, which are bigger, higher performance. These, again, are what's used in data centers and high performance computing. So we have a single board that could go into a robotaxi that is able to process 2,000 TOPS. So again, 2,000 times a trillion operations per second. And so all of that is used to take the radar, the camera, the LiDAR data, and use artificial intelligence to make sense of that. What is going on around the vehicle completely, and use that to make driving decisions. So it's a very compute intensive task. So we have that platform as the core. Then you asked about an operating system. So we have our Drive OS software. We have a lot of libraries and algorithms and routines for doing everything from pedestrian detection to lane detection to sign reading, but also things that operate inside the car where we can do driver monitoring with eye and gaze detection, head pose monitoring, facial recognition. You could imagine, right, the car unlocks based on your Face ID. Conversational AI, you will be able to just have a regular conversation with your car rather than having to go to the cloud all the time to decipher what it is you're saying. So there's so many capabilities inside the car and the sensors outside the car that, again, it's an open platform. So different app developers could add their own software, and it's really up to the OEM to decide that feature set. So we provide this hardware and software platform for them to build and customize depending on their use cases and their brand look and feel.
Thanks for that. So that is expected, and I think it makes sense from your point of view, from a business case, because at the end of the day, you need to have a scalable business where you can sell your products, be it services, software, or hardware. Do you see challenges around tailor-made solutions like, again, Tesla is doing or others are doing in the market versus your approach, which is if I understand correctly, on the one side modular, on the other side it allows extensions and adjustments to the needs of the customer.
Well, again, I think we all know, and we've heard many guests that you've had or interviews you've done talk about software, right? This is now a shift. NVIDIA is a software company. We started out as a hardware company. We now have many more software engineers than we do hardware engineers. We make both, but the future is software. We have done a lot of work where we started in gaming, of course. That's what people know NVIDIA for. And that's what was the first use of high performance computing, but we're really a computing company. And AI is the new wave of computing. It's a whole new model of computing. And we've evolved into data center and supercomputing as well. So now what we've done is we've gone up to the high end and we're bringing that technology down into a vehicle. And so we're able to deliver the types of solutions. Again, it needs to be software-based because it's changing so fast. It's not fixed functions, but we are a software company then that is that go-to source for the auto industry. Very few companies have that type of expertise in-house. We've seen cases of traditional automakers really struggling on their software, and you can't just say you want to be a software company and become one. It's a very different talent set. And again, we've built our company from the ground up now to be a software company. So we're available to partner with the industry and to be their software company.
So who would be your natural competitor? What is your definition of, I mean, I know NVIDIA, I've been a shareholder of NVIDIA for many, many years, and I've been a big fan from management to your product and other things. But obviously, over the years, there are new players around, bigger and smaller players. So how would you define your competitive landscape?
But you're right. I think there's a lot of new chip companies that are starting. They're trying to come up with AI algorithms. And the reality is what they tend to do is focus on a specific aspect of AI or a specific neural network or something where they can tune and optimize and hard code it. And that's really the old school philosophy. If you think of the auto industry, you had all these independent ECUs that were fixed function. And so the field of AI is evolving so fast. We've created a high performance processor that is programmable, it's open. And so that's why you see NVIDIA winning all the AI benchmarks essentially, because we have the horsepower and the flexibility to adapt to all the new types of algorithms and the research that's going on. We've also created a whole end-to-end workflow. And I don't know of anybody else in the industry that has this. So from taking vehicles on the road and collecting data, to ingesting that into the data center, to curating that data, to labeling that data, to train the AI, to test and validate, to use simulation. It's a whole workflow and process, and it's all based on NVIDIA. So even our competitors that have other chips that they're trying to sell don't have that level of platform integration that we have. And in fact, they use NVIDIA to train their AI. And so we're unique in terms of what happens in the data center and runs in the data center is exactly the same as what's running in the vehicle. And we can do something that's called hardware in the loop testing and simulation. So we actually put the drive computer that goes inside of a vehicle, we put that in the data center to test it. And we can simulate driving millions or even up to billions of miles in really dangerous bad weather conditions, bad lighting conditions, all these kinds of corner cases that are very rare and you wouldn't see in the real world, but we can test it over and over and over, tune the software, make the adjustments, do it in a safe environment, and then once we feel it's ready, we can then put that whole hardware and software in the vehicle and then test it with our safety drivers on the road.
So let's dive in that a little bit, because there's a highly controversial discussion going on in the market about real life data and simulated data. I personally have worked for simulation software companies many, many years of my life, and I've been driving actually everywhere where you can drive as a car, from Australia to Asia to Europe, obviously, North and South America. And if we talk about corner cases, there's a full pattern of pictures plopping up in my brain. So what I'm trying to say here is I'm struggling a little bit with simulated data to train algorithms. And I know you just explained your approach, which is actually exactly that. So there's no surprise here. The question I have is, if you train with simulated data an algorithm, the algorithm will be based on that what the simulation is giving. And before, as a preparation for this interview, I've been looking at your simulated data videos, which been fantastic roads, which very nice lane markings, and the ramp up was nice and everything was going frequent, but that's not the reality we are seeing out there. How are you coping with that?
No, you raise a really good point, and we're not advocating just using simulation. It's a tool, and it's a way to augment. So we do a lot of training based on real data. We have cars, and our customers have cars that are driving around collecting real world data. So that's a big part of that. What the simulation does is let us create all these dangerous and hazardous scenarios to test and validate the software. And so again, being gaming and photorealistic rendering, and essentially all the Hollywood studios and visual effects houses use NVIDIA, I think, as you know, to create real world. So we can create, and the goal is to create photorealistic and model the sensors, not just cameras, but using 3D techniques to model the radar and the LiDAR sensors. So essentially, we're tricking our computer that's in the data center to think it's on the road. We're feeding it the data sets as if it were driving on the road to see how it would react. And so we're able to very quickly iterate and test and validate, and then put it on the road. And then we do, obviously, on-road testing. So we're not trying to skip a step. We're doing everything to be as safe as it possibly can be. But we're able to then inject all kinds of other use cases and scenarios that you just won't see driving around, right? There are a lot of accidents, a lot of injuries that happen every day on the roads. But you as an individual driver almost never see them. What we can do is collect all that data of everything bad that happens, and we essentially are building these massive scenario databases. And this is working within the industry. So whether it's from NHTSA or other regulatory agencies, we can get databases of these scenarios that are dangerous intersections or known accidents or other problems. And we can then test our vehicles against all these different kinds of scenarios. And every time we build new software, we need to go back and retest. And so again, it's something that isn't practical to do in the real world, but we can then have the exact same scenario, bad lighting, it's sunset when you're blinded, whatever it is, when the child runs out across, and we can continue to repeat these and to make sure that the software gets better and better and better before we actually put it on the road.
I understand that, so that makes a lot of sense. Where I'm coming from is, my question is more the different driving scenarios. You just have very different roads around the globe. So
absolutely.
So the question is, where are you driving your real life data that you're collecting and using? Where are you doing that?
So we have a relatively small fleet at NVIDIA. And again, we're not deploying the ultimate vehicles. We're not creating our own robo-taxi service, but we have to understand the entire problem to be able to develop the hardware and software. So we have cars based in the West Coast, in Northern California, and we have offices in Washington. We have several vehicles that are in the Midwest that are being used there, on the East Coast in one of our facilities. And then we have vehicles in other regions, in China and Japan and Germany. But again, this is what we use to create kind of the core of the software initially. And then working with our customers, they will be deploying the larger fleets and doing more on-road testing and collecting miles. So of course, the goal is, and the requirement is, to have extensive testing wherever these vehicles will be deployed. The benefit, again, of simulation is we can create models of different environments, different road systems, different lane markings, different signs, all of this. So there's the process, again, of training it. You have to recognize, obviously, different languages, different colors of signs, different colors of lights, whatever it is that's unique for each region, that all becomes part of that training for that domain. And then we can also use simulation to test and validate it.
So you're obviously, of course, depending very much also on your customers in terms of what kind of data they are providing to you. Who is ahead? I mean, who is leading here from your customer base in terms of developing solutions, be it right now probably level 2 or level 3, because that's where we are right now. So what are you looking at
Well,
here?
what we see are the companies that are, again, adopting a full workflow. It's not just about having a product, you put it in the car. So we announced in the past, Toyota is using NVIDIA from end to end. So from data collection, training, simulation, and deploying, it's a whole pipeline. And then it's a cycle. It goes right back because software is never done, right? You're always improving, you're adding new features, new capabilities, and then OTA. So we announced that Toyota is using NVIDIA end-to-end, Volvo Group, which is for Volvo trucks. Again, end-to-end from data collection and looking at how do you introduce different levels of autonomy over time. You can make the cars more and more capable as regulation then becomes set and approved, and there's validation processes. Once you've put the sensors in the car, once you've put the centralized AI drive computer inside the car, you can then update it and evolve that vehicle over its life.
So what are the use cases you're looking for first? I mean, truck business is often mentioned as a kind of a natural fit for obvious reasons. But also passenger cars are obviously an interesting, attractive use case, and there are different approaches. I mean, we see how Waymo is approaching that, or Cruise, and other players. Tesla has a more holistic approach, which goes already in different markets, where Cruise, for instance, is just enabled on certain roads, I believe, in the US even, which requires an HD maps and other things. And they all work kind of with LiDAR, or a lot working with LiDAR, let's put it like that. While, again, someone like Tesla has a different approach and is pointing out that vision is key, and without vision, you won't solve it. What is your standing and thoughts here about vision, LiDAR, the other sensors? What is really required to make it work? And if I say making it work, I mean, the highest I'm talking here is probably level 4, which would be an extremely leap forward already. You have a Tesla, you know what your car can do. I have a Tesla, I know what my car can do. So, and you have probably more experience with other players in the market. So I'm interested in all the different data feeds that are getting in the CPU, GPU, and the information is used, and then we later on go a little bit in the algorithms, because I'm interested in that as well. So first on the sensors, what is your standing? What do you believe is really required to make it work?
Again, our number one priority is safety, and hopefully everyone else has that same philosophy, right? We don't want to put anything out on the road that is going to create a bad outcome, be harmful. The world is an unpredictable place. There's over 1 million people that are killed every year in car crashes, and we know this technology is going to make the world a much safer place and a much safer way to travel. That said, so we believe that the keys to safety are redundancy and diversity. And so that is part of the sensor strategy. So having a variety of different sensors that complement each other, and different algorithms, and overlapping sensors. So it's really the more diverse sensors you can have. So cameras, infrared cameras, radar, LiDAR, sonar, they all have different strengths and weaknesses, and they all excel in different types of applications. So the more you can have on that car, the safer it's going to be. There is, of course, a cost constraint that makers of these vehicles have to face. And so it's a trade-off they're constantly making to figure out how do they provide that full kind of security cocoon around the car, but do it in a cost-effective way that people can be able to enjoy the autonomous vehicle and afford it. So again, I think that's where you've seen like this first wave as you start to put more expensive sensors on the vehicles. It may be out of the price range for a passenger vehicle, an individual consumer. And so you look at these robo-taxi services, you look at trucking commercial types of operations. That's where it's sort of been projected out. Those would be the early adopters in the first deployments. I think in the time of COVID right now, we're seeing a huge increase in demand for shipment of goods, right? People are staying home, they're not commuting to work, they're not shopping other than online. And the deliveries, whether it's food, groceries, or products from an Amazon or Walmart or other types of similar services around the globe, there's a need for movement of goods. And so I think we've seen a recent shift or acceleration of that shift to transporting product versus people. And I think, again, those deployments on the highway, hub to hubs, and we've been working on a lot of those programs, and we'll just see more of that, as well as last mile delivery, low speed, whether it's smaller devices that are operating on sidewalks to vehicles that will operate 24/7 to deliver packages. So those, in terms of timing, we'll see a lot more of that before more level 4 robo-taxi kinds of application. I mean, there's places today you and I can't drive, it's just not safe, or weather conditions, it's not safe. So I don't think it's realistic to expect autonomous vehicles to go in those roads or those conditions. But there will be a lot of geofence deployments, like you said, certain roadways, certain environments, certain speed limits that we'll see in the near term being deployed, with more to come.
So talking about LiDAR again, and you talked about the cost associated here, and we all know that LiDAR is not cheap, and which is probably limit its business case to just certain areas and not for the, let's say, ordinary passenger car. But the other thing I'm asking myself is, LiDAR is in the resolution and in the way the data is collected, extremely precise, accurate, and granular. So you have a picture of the world which is amazing, but the question is this really required for driving a vehicle? And I'm asking myself, what is the perfect set of sensors? So imagine you would take your cap off and you would start your own company for a second. And you would ask yourself, what are the sensors I want to select, regardless whether this is for an OEM or whether you are building the vehicles? What would be your perfect structure?
Yeah, so again, I think that the key is diversity. And the last thing I want to do is have one of my vehicles be responsible for an accident on the road. And I would want to do everything I could to ensure that doesn't happen. And so I believe there needs to be a comprehensive diversity of not just cameras, but other things that can do better at gauging depth and being able to discern a full surround environment, and be able to handle different types of lighting conditions and different weather conditions. So yeah, the combination of camera, even infrared camera with radar and LiDAR. Now, the LiDAR is coming down. There's a lot of startups. We work with many of them, and I do believe we'll see very affordable LiDAR in the near term.
Okay. And in terms of use case, you also believe that it's still going to be used? I mean, okay.
I do.
So another important aspect you just mentioned a few times, and I fully agree to that, is the security risk and danger of accidents. And you're right. I mean, the world is a dangerous place. There are accidents all the time. While we speak here, I don't know how many accidents did happen. And it would be an illusion to believe just because we have autonomous vehicles, there are not going to be accidents. At least this is my point of view. Even if the autonomous vehicle is doing everything perfect, you're still going to have all the other members in the situation that are probably making a lot of mistakes. So I think, I mean, what we see already, if you look at first data, is that AI-driven systems are way safer than a human driver on average. Let's that average is important, because you're going to have exceptions, extremely careful, good drivers who've never had an accident in their whole life. But I think it's going to happen sooner or later. We're going to have see accidents with autonomous driving systems. And we've seen this already with Waymo and also with Tesla. There's been accidents. Do you believe there needs to be a 0.1 or 0.01% accident rate, or how do you approach that? The regulators are looking at this, obviously. And I also feel there's a lot of fear in the market from the people that this kind of artificial system in the vehicle is kind of a threat.
Right.
How are you managing that from NVIDIA?
You raise a lot of really good questions. And I think so that there's a couple of aspects here. One is we know that the systems don't drink, they don't get drowsy, they don't get distracted. So right off the bat, we eliminate a lot of accidents. As long as you have all these other human drivers out there, there's people running red lights and driving recklessly and having road rage. So the autonomous car cannot prevent other people from doing bad things. The autonomous car cannot prevent other people from hitting it or creating situations that are just unavoidable. The regulators do have an opportunity to play a role here in terms of, if you look at how seatbelts or airbags were optional at the beginning and then became requirements for vehicles. We have a lot of technologies that could become standard in vehicles that don't have to be fully autonomous, but could still be a lot of these emergency-based systems that we're building into an AV that could be part of consumer cars. Now, the fastest way to get that accident rate down is to just make all cars autonomous, right? And then you don't have the human error. And there may be some regions that do that, right? There may be some new road networks that are autonomous roads only, right? Autonomous vehicles on these roads only. There may be some cities where pedestrians are raised and all the pedestrian walkways are on a different level, because what we've seen in recent years is pedestrian accidents and fatalities have gone up, partially because of distracted driving, but a lot because of distracted pedestrians. And so all it takes is two people on their cell phones, one walking and one driving, and it's a bad outcome. So if there's actions that regulators can take, city planners will go hand in hand with autonomous vehicles, I believe. So there's a whole shift of how we can do this. But the ability for these cars to sense everything around them becomes superhuman. And it's not that the car is having to have its own set of ethics. I think that's a misconception people have. How is the car going to decide to do this or that? It's not that the car is programmed for that. The car is designed to avoid those dangerous scenarios. And it's going to sense there's problems way in advance and take evasive action, slow down, whatever, change lanes, whatever it is, before it gets to that last minute reaction that humans often will face themselves in because they haven't been paying attention.
So you're talking actually about recognition and cognition here, which is another very interesting field in the world of AI, and we don't have the time to dig that deep into that. But a quick question is, do you believe there's going to be in the future a chance to go from recognition and make the step to cognition?
No, we're eventually going to have machines that are capable of more than that. I don't know what the time frame of that is. What we've done is deep learning is this field of artificial intelligence that is able to give the computer superhuman abilities on specific tasks. So it's not free thought that we're doing, but it's the ability to detect, like you said, what's happening in the environment better than any human. We can do it a full 360 degrees. We can do it 30 times a second. And so we know everything that's happening around that car. But to be able to make kind of free thought types of decisions, I have no idea when we're going to be at that level. And again, that's not what we're working on for autonomous vehicles.
No, and I didn't expect that. I think this is an exciting field and interesting, and we all don't know how this is going to develop. Maybe it takes a very long time. Maybe it's going faster than we believe. It's hard to say. I think one of the challenges here is that pedestrians, drivers, and bicyclists on the road gonna see an autonomous driving vehicle. they may be able to recognize it as self-driving. And they immediately start to try to find eye contact or other things in order to manage the situation, which doesn't work with such a machine. Right?
You raise a good point. And so there's opportunities for the evolution of the user interface for the occupants of the vehicle, and we're doing a lot on that front. We have what's called Drive IX. That's our software platform for the intelligent experience inside the vehicle. So using AI to combine sensors inside the vehicle with outside. And so the car is able to know, is the driver, the occupants paying attention? If it's in a driver assist mode, the system can alert people to a cyclist. Maybe the driver is looking this way and someone has walked off the curb that way, and the system would alert them. If they know the driver's looking at that pedestrian, they don't have to provide that alert. So there's a lot of intelligence we can bring in. Somebody, maybe you've turned off the car and you're about to get out of the car, the sensors can still detect a bicycle coming right along your door and provide an alert or prevent you from opening that door into that cyclist. So there's so many ways to use the sensors to improve the experience inside the vehicle. As we talked about, there's conversational AI and many other types of convenience. There's this evolution of the vehicle. And again, being able to provide, get the superhuman capabilities to be always alert to make the people inside the vehicle and the people outside the vehicle safer. Now, you also talked about that communication with the external world. This is something that we're working with our automaker partners on, is how do you communicate to the outside world? And there have been some prototypes and some interesting concepts there. There could be some LED arrays. There's some potential lighting that shows a car is being driven in autonomous mode versus human mode. There may be some auditory signals. There may be some other communication signals to indicate, just like people at a stop sign would wave for each other to go. There could be some more universal signals. And I think that's something for the industry to come together on is, there's standards for brake lights and blinkers and things like that. I think it would be useful to have standardization of some kind of signals that show this is an autonomous vehicle. It's now in autonomous mode versus manual mode. It's going to indicate its intent, it's stopping, it's waiting for you, whatever it may be. So I think we could see an evolution across the industry of lighting or other types of ways of communicating.
Fascinating. I think we could probably talk hours about it because I believe this is interesting what you're saying, and I agree. But it has implications. It also would mean that how we behave in traffic and how we learn to drive would change completely, right? So it has a lot of interesting implications, complications that are coming with it. But in the interest of time, let's change topics a little bit and talk about the algorithms, the self-learning algorithms you are using in your training with mapped data, with real life, with simulated data. And I'm interested, let's go a little bit deeper than the normal conversation in terms of, we know that algorithms have this ability to get trained with the right data input. And if you look at a human, we are absorbing, I don't know how much data we're absorbing in a normal traffic situation. It's crazy. And probably 99.99% of that, it's just garbage for us to react in the right way, right? The same kinds is of course true for a vehicle in a situation like that. So the question I have is, let's put it like that. In the beginning of the discussion years ago, there was an approach like, well, this is a piece of cake. We have a street, we have line markings, we have a rule-based system, so we can define what it does. So for us as software guys, you just program it and here you go. And then it got more complicated and complicated, right? And now we have this tons of sensors and a crazy amount of data. And you guys are doing a great job with fantastic computing systems that are absorbing and computing this data. But the question I have is, how do we make sure that we are just working with the data that's really needed? Because on the long run, to compute everything that you can absorb doesn't solve really the issue you have in that specific situation. And it does also create some challenges around cost, around heat you're creating, about energy you're consuming with your computers, which I believe are a couple of reasons Tesla mentioned why they decided not to work with NVIDIA in that area anymore. So how do you approach that? How do you see the future? Where are you standing right now?
I think let's start with the algorithms. And again, it's important to recognize there's two kind of phases to this computing challenge. The first is the training. So we collect a lot of data and we're training many, many algorithms on that data. There's a deep neural network for pedestrian detection. There's a deep neural network for lane detection. We have a neural network that's computing distance. We have one for detecting intersections, which if you think about it, that's not really a specific thing. It's more of an intersection as a concept. Again, the list goes on and on. So there's dozens of these individual deep neural networks that we're training and perfecting. And then it's kind of, they come together once they've been trained. We're running them what's called inference. So at that point, while we're driving, the data is coming in and we're analyzing that data in real time based on those neural networks that have already been trained. So we're not teaching the car's not learning as you drive. It's been trained, tested, and validated in the vehicle. So it's very efficient while it's running in the car. And we're able to then use this diversity of different types of approaches where we're detecting objects, but we also have a deep neural network that detects free space. So it's the opposite. It's the absence of objects. Where is it safe to drive? Which is more how you and I would drive. It's like, oh, I see there's no car in the lane next to me. I know I can change lanes. Rather than I see this, I see this, I see this, I see this. So it's this combination of different algorithms running that provides that safety and that redundancy of overlapping sensors, of different types of sensors, different types of algorithms that again paint that picture. You've probably seen some of the demo videos, whether it's ours or others, that you see these wire frames of the people and the cars and the lanes and everything. So the car, it almost looks like a video game. The car is trying to move through this virtual world that's based on the sensed real world. And so again, there's a combination of AI plus certain rules. We know if light turns red, you have to stop. The assumption is when other people have a red light, they're going to stop. But we're also watching to ensure that if they don't stop, we're not going to pull out into that intersection. So again, there's all kinds of driving rules that are based on what we need to do to ensure safety combined with the AI. It's a very complex software stack. We provide the whole stack, and as I mentioned, gives the ability for our customers to add their own algorithms. If Mercedes-Benz wants to use its pedestrian detection algorithm, they can do that. And there's no reason why we wouldn't have two pedestrian detection algorithms as a redundancy in the system. So it's a combination of NVIDIA software plus our partner software that ensures the highest level of safety.
So redundancy is an important word in terms of autonomous driving. You probably have two systems running in parallel and comparing at the end, or how are you approaching that?
There are a variety of different approaches, and it depends on the level of autonomy. For a level 2+ system, the backup is the human that's responsible for the system. But as we go to higher levels of autonomy, there are backup systems. So some approaches are, like you said, doing the same thing in parallel. The challenge of course of that is that if there's a failure or a problem in the system, you're replicating that failure on both. So having that diversity of algorithms, of process, of just the overall system is important. But there's also fail-safes. So there's a backup. Maybe it's not a fully functional in terms of all the capabilities, but if there's some kind of a problem with the primary system, there's a backup system that is able to handle the situation and put the car into a safe state, slow it down, stop it, pull it over, whatever it needs to do.
Yeah, I think I agree to safety rules, let's put it like that. But in terms of if you have two redundant systems, I would argue that with a trained algorithm, they wouldn't come to the same conclusion necessarily. So as a human in traffic, we all find conflicting situations, and probably we stop and we look around and decide what we do because there's a bicycle coming here and one there, and we don't know what's happening. And the same is happening with the systems and algorithms, but I believe there is still a lot of changes going on. And obviously I follow Tesla a lot simply because there's a lot of information available, how they're approaching that. And there's a lot of discussion about vector-based, and they've been reprogramming a system. You probably heard about the Dojo project. So there's an automation going on in terms of mapping, framing, and other things. Here in Germany, a little bit typical German discussion, although it's also happening in other places of the world, is there's a lot of thinking about HD maps and enabling autonomous vehicles on certain roads just there, which probably gonna work fine. As you just mentioned, you can dedicate certain lanes and then you have solved it pretty quickly to a certain extent. It's the same with trucks. You can define certain places where they can drive and that's it. And then you can claim you have managed it. But for a normal passenger, this is obviously not a use case he's very much interested in, because I don't know, you go to a party, you're drunk and you want that your car drives you home, which is a normal use case for a lot of people. Or a girl wants to make a makeup while she's driving to work. Not that they are not doing this already today, but we all know that these are the usual situations. And if I look at myself, and probably you have the same, I'm engaging the system, the autopilot system, in situations where I search something, I want to get the bottle open or whatever, and I feel more safe because the system drives in a situation where I know that this vehicle is managing the situation pretty well. So what I'm trying to say is I feel like with every year going by, there are more players, there are more approaches in the market. There is not only more hardware and sensors and chips and software approaches. There are a lot of promises, let's put it like that, in the market right now. And what you guys are doing is definitely one of those. And it's clear that what Tesla is doing is certainly a nice way to go, but we all know that there's a huge variety of automotive companies out there that need such a solution, because the winner probably gets it all. So the question is, who is going to win this race? Who is going to be the first one who has a widely used passenger car solution in the market that really satisfies, let's say, level 4 for the regulators? The UNECE has just approved or came to an agreement about something that I call traffic jam assist. You're certainly aware about that. And it may take a long time if you come to a level 4. But who's gonna be in front here? What is your thinking? And I'm talking about passenger cars,
right?
Normal people, not even robotaxis, just being able to drive hands off and do something else.
So this will go full circle to how we started, really, is the approach needs to be redesigning the architecture of the car to be a software-defined car.
Yeah.
And the announcement we made with Mercedes-Benz is exactly that. It's standard across every next generation car. So whether it's an entry level, the most affordable A-Class to an S-Class, ultimately starting in 2024, all the new models that roll out will have this whole new architecture, software-based, surround sensors standard on the car, and the ability to purchase those features that you want at the time you take the car home, but also the ability to add those. So it's a change in the business model for car companies. And I think that's really going to be revolutionary.
I agree fully, and I think you referred before to my articles. I've been pounding on that since a long time, that in particular here the German automakers, which is actually the reason why I started to write and to get a little bit more public, I believe miss that DNA, and they miss and I can say this, you probably don't because you're customers, but I can say that I feel like there's a misunderstanding what kind of change is really required in order to make that what you just described happen.
No, we've believed this since we started in the auto industry, and our first wave was just an infotainment. but it was a programmable system. It was an updatable system. And we had customers like Audi, BMW, Honda, Tesla, all using our infotainment solution. Yeah. And only one of those really was updating it. But it was flexible in that some were running the QNX operating system, some were running Android, some were running Linux. It was a true computer. And that was our first model, which then we extended into autonomous vehicles. And now you see the flexibility that we provide, the scalability we provide, and the openness we provide is what's enabled hundreds of companies to use our solution.
Very good. In the interest of time, I think we need to conclude. My last question to you is an open question. Is there a question I should have asked, or is there something you want to convey here to the audience?
I think one of the things that we're really proud of doing is, again, creating technology, but then also helping to educate the industry. So there's a series that we've put out on YouTube called Drive Labs, and maybe you can link to it or something, but it's designed for people in the industry as well as people who are interested in learning more about autonomous vehicles. And it's hosted by one of our engineers. And it are these just 90-second video clips that dissect one little problem out of the many, many problems that we're trying to solve in developing autonomous vehicles. But this whole series gives great insight into the numerous building blocks that go into creating an autonomous vehicle.
So I've seen a few of those and they are really good. So I'm definitely going to link this that people will find it who watch this video. But what you're saying, which is actually even more important, is education. And I believe the development in autonomous driving vehicles requires from all of us education and learning in terms of dealing with something which is completely new and people haven't seen before. And usually if something is new, what you haven't seen before, you're afraid. It's a threat. It's something dangerous. And that's how the systems are seen from many people. And I believe, as you indicated before, by definition, the systems are more safe than a human driver. So education can help a lot people to understand that this is something which is helpful and that can save lives, that can save their life, and that makes our all life better. So having said that, I want to thank you very much for your time. It was a pleasure.
My pleasure too.
Really interesting thoughts, ideas, insights. As I said, we probably could have spent 3 hours, maybe in the future one day, we will see. But I want to thank you.
My pleasure, and thank you very much to all your subscribers and viewers.
Thank you. This was my conversation with Dennis Shapiro from NVIDIA, one of the leading companies in autonomous driving. If you enjoyed it, subscribe, like, and leave a comment. If you want to follow me, you can do on Twitter or join in as a patron.